The World of Rocks and Minerals by Donna Watson. Minerals all around. You use minerals all the time. You use them when you write with a pencil, which contains the mineral graphite. Talcum powder, which you rub on your hands before doing gymnastics, is also a mineral. You are even walking on minerals when you walk down the sidewalk. What are minerals? Minerals are natural, non-living, solid crystals that make up rocks. No matter where a mineral is located, it will always have the same chemical makeup as materials of the same type. Biotite is a type of mineral mica. A sheet of biotite could be found in the Black Mountains of North Carolina, or a small chip of biotite could be found on the Pikes Peak, Colorado. But both would have the same chemical properties. Biotite is a type of the mineral mica. Some of the rocks in Pikes Peak below contains biotite. Scientists have found over 3,000 different minerals, but most of Earth's crust is made up of only very few minerals. These minerals are called the rock-forming minerals. Some rocks are made up of just a single mineral. For example, some limestone is made up of only the mineral calcite, but most rocks are made up of different minerals combined. You will always find the same combination of minerals when looking at a certain type of rock. For instance, slate is always made with quartz and mica. Limestone, above, might only contain the mineral calcite, right? Identifying minerals. Each mineral has specific properties or characteristics. Scientists use these properties to figure out what mineral something is. Some of the properties tested are colors, luster, hardness, streak, cleavage, and crystal shape. Color. The easiest mineral property to find out is color, but usually color is not enough to determine the identity of a mineral. For example, there is more quartz in Earth's crust than any other mineral. Pure quartz is clear, but there is also purple quartz, which has bits of iron in it and is known as amethyst. Rose quartz has magnesium and titanium in it. In the same way, the mineral calcite can be many colors, including white, pink, or yellow. It could also be colorless. So scientists need to use properties other than color to find out what mineral something is. Quartz below has a clear color. Purple quartz, right, is called amethyst. Luster. Luster is the property of how a mineral reflects light. Luster can be glassy, having a look like glass. Luster that looks like polished metal is called metallic. Minerals can also have a greasy, waxy, silky, dull and chalky, or pearly luster. Hardness. A mineral's hardness is found by seeing how easy or how hard it is to scratch. Scientists use the Mohs scale, which uses numbers from 1 to 10 to rank hardness. The softest mineral, talc, has a hardness of 1. Diamond, with a hardness of 10, is the hardest mineral. Any mineral can scratch another that ranks below it on the scale. For example, feldspar has a hardness of 6 to 6.5. Mica has a hardness of 2 to 2.5. If you rub feldspar and mica together, the feldspar would scratch the mica. You could use your fingernails to scratch some minerals. These 5 minerals are examples of some of the ranks on the Mohs scale: gypsum, fluorite, feldspar, topaz, diamond. Streak. As you know, some minerals come in many different colors, but a mineral will always leave the same streak, no matter what color. Streak is the color of the powder that a mineral leaves when it is scratched across a special plate. It can be different from the color of the mineral that makes it. For example, pyrite is gold, but the streak is greenish black. Crystal shape. Minerals do not always have a shape that is easy to see, but when you can see the shape of a mineral's crystal, it can help you tell which mineral it is. Crystals are grouped by their shapes and angles. There are 6 types or classes of crystals: Quartz has a crystal that looks like a six-sided prism with a pyramid at each base. Galilean's crystal are cube shapes. Pyrite streak, quartz crystals. Cleavage. Mineral that break along smooth, flat surfaces have cleavage. The topaz has perfect cleavage. It breaks into parts with perfectly smooth surfaces. Quartz has no cleavage. It usually breaks into pieces that look like the inside of a seashell. Other properties. There are even more ways to identify some minerals. Pyrite and magnetite are attracted to magnets. Different minerals feel different when you touch them. Talc can feel greasy or soapy. Kyanite feels smooth. Other minerals may feel sandy, powdery, or sticky. Minerals may have memorable smells or tastes. Pyrite smells like rotten eggs. Halite tastes like salt. Other minerals can be identified using chemical tests. You can make calcite bubbles by placing a drop of vinegar on it. Magnetite attracts nails and other metal objects. This helps us identify it. Rocks and minerals as resources. One reason we study rocks is because they contain many valuable resources. An ore is a rock rich in valuable minerals that can be removed from Earth's crust. Ores are mined to get the minerals from them. Iron ore is one of the most plentiful and useful of ores. The metal iron is taken out of iron ore after the ore is mined. Iron is used to make steel. Beams in tall buildings, cars, pots, and pans are all made of steel. Two other important mineral ores are graphite and calcite. Graphite is a black or gray mineral. It is used in pencils, as you already know. It is also used to make lubricant. Calcite is used in cement. The steel used to build parts of cars comes from iron ore. Pencils contain graphite. Hematite. The most important source of iron ore is hematite. Hematite is made of iron and oxygen. About 7/10 of hematite is pure iron. It can come in many forms. One form has a shiny gray six-sided crystal, while other forms have reddish-brown coarse grains. Reddish-color hematite is used to make red paint. Hematite can also be used to polish glass. Hematite has been found all over California. It can sometimes be seen on Earth's surface where it turns the soil red. It is often found near silver mines and in quarries. Hematite blue is one type of iron ore. The steel made from iron ore is used to build bridges as well as cars. Galena and lead. Galena is the most common source of metal lead. It is a gray mineral with a metallic luster. People have been getting lead from galenite for over 5,000 years. There are two major sources of galena in California. One source is near Darwin in Inyo County. The other is Tuolumne. Galena and lead. Galena is the most common source of metal lead. It is a gray mineral with a metallic luster. People have been getting lead from galena for about 5,000 years. There are two major sources of galena in California. One source is near Darwin in Inyo County. The other is Tuolumne County, Jameson's mine. Lead is a dense blue-grayish metal. It can easily be shaped and pulled into wires. One of lead's most important uses is in a part in car batteries. In the past, it was used to make parts of buildings. It is still used to make parts of roofs. It is also used to shield people from radiation. Lead was once used in paint and in fuels, but it was found to be poisonous to people. This is why other materials are now used instead of lead for certain things. Lead is an important part in car batteries left. It is found in galena below. Copper. People have used copper for thousands of years. It is a shiny metal that is easy to shape and make into wires. Rocks that are that formed from lava often turn out to be copper ores. People crush the rocks together to get copper. Chalcopyrite is a common copper ore. Copper is often used in electrical wires. This is because electricity flows through it well. Copper wires are found in motors, generators, and many other devices that use electricity. Copper is used to make pots, pans, coins, and musical instruments. When mixed with other metals, it can form bronze and brass. In the 1800s, copper was mined in California in many places. It was mined around Placerville in El Dorado County and near Clark Mountain in the Mojave Desert. Today, there is a large copper mine near Salt Lake City, Utah. Copper pot. Copper. Using tables to identify minerals. When scientists want to identify a mineral, they first observe all its properties. Then they look at a table. The table shows the properties of many minerals. Use the table below to identify the minerals on the next page. Mineral: copper, galena, hematite, mica, pyrite, quartz. Color: copper red, lead red. Gray: silver gray or red. Dark brown, black, or silver white, gold, clear, may be colored by impurities. Luster: metallic, metallic or non-metallic, pearly, metallic, glassy. Hardness: 2.5 to 3, 2.5, 5 to 6, 2 to 2.5, 6 to 6.5, 7. Streak: copper red, gray, reddish brown, white, greenish black, white. This mineral color and streak are the same. This mineral has a metallic luster and a lead gray color. This mineral can have a metallic or a non-metallic luster. This material is softer than every other mineral listed in the table. This mineral has a gold color. This mineral is harder than every other metal listed in the table. Igneous rock. One way scientists classify rocks is how they form. Rocks that exist in deep beneath Earth's surface can become so hot that it melts. This molten rock is called magma. When magma cools, new rocks will be formed. Igneous rocks form from the molten rocks. The Greek word igneous comes from Latin. It means fire. Igneous rocks can form deep underground and at Earth's surface. These rocks are usually hard. They have interlocking crystals instead of layers. The molten rock in this volcano is called magma. Lava. When a volcano erupts, lava can burst onto Earth's surface. Lava is the name given to the molten rock after it reaches the surface. Once lava is on the surface, it cools quickly. It may only take a few days to become solid igneous rock. Minerals, crystals, form as lava cools. When lava cools quickly, minerals, crystals do not have much time to form. This causes only a very small crystals to form. Rhyolite is a light-colored igneous rock that is made up of quartz and other minerals. Some lava cools in water. Basalt is an igneous rock. Its color can be either dark green or black. It often forms under the ocean. Open ocean water cools lava very fast. Igneous rock forms following a volcano eruption. Left, basalt below is one type of igneous rock. Magma cooling underground. Sometimes magma cools off and forms rocks when it is beneath Earth's surface. This magma rises slowly towards the surface, sometimes forming cracks along the way. While the magma is rising, it may melt the rocks around it. Slowly, the magma cools. The slow cooling allows big crystals to form. Eventually, the magma hardens into igneous rock. The magma beneath Earth's surface can take more than 1 million years to become a rock. This scientist is studying a pool of lava. Gabbro, right? An igneous rock forms from lava cooling on the ocean floor. Types of igneous rocks and their uses. Igneous rocks forms beneath Earth's surface forms rocks such as granite. Large crystals of quartz, feldspar, and mica are found in granite. Gabbro and diorite are two other rocks that form from magma when it slowly cools. Igneous rocks are very hard, which gives them many practical uses. Granite is probably the most well-known igneous rock. It is often used to construct buildings. Many schools have granite foundations. Sometimes granite is crushed into smaller rocks or gravel and used for roads and driveways. The igneous rock, granite, left, is used to build many things. Sometimes it is crushed to make gravel, below. Sedimentary rocks. Sedimentary rocks form when layers of sediment settle on top of one another and harden. Sediments are made up of soil, shells, bits of rocks, and dead plants and animal matter. Sediments are moved from place to place by water, wind, water, ice, and gravity. With time, many sediment layers build up on the bottom of the oceans, rivers, and lakes. The new layers press on older layers. Sediment particles are held together by the weight of the layers, sticky clay minerals, and chemicals. Newer layers of sediment rock are usually on top of older layers. Knowing this helps scientists study the ages of rock and living things from long ago. Fossils found in a lower layer are usually older than those found in higher layers. Layers of sedimentary rock left can contain fossils of animals as well as fossils of plants, below. Types of sedimentary rock and their uses. Sedimentary rocks are usually soft and layered. Their layers can contain broken bits of older rocks. Materials in the sediment are used to classify sediment rocks. Limestone can form from pieces. Sedimentary rock. Sedimentary rocks form when layers of sediment settle on top of one another and harden. Sediments are made up of soil, shells, bits of rocks, and dead plant and animal matter. Sediments are moved from place to place by wind, water, ice, and gravity. With time, many sediment layers build up on the bottom of oceans, rivers, and lakes. The new layers press on older layers. Sediment particles are held together by the weight of the layers, sticky clay minerals, and chemicals. Newer layers of sedimentary rock are usually on top of older layers. Knowing this helps scientists study the age of rocks and living things from long ago. Fossils found in a lower layer are usually older than those found in a higher layer. Layers of sedimentary rock left can contain fossils of animals as well as fossils of plants, below. Types of sedimentary rock and their uses. Sedimentary rocks are usually soft and layered. Their layers can contain broken bits of older rocks. Materials in the sediment are used to classify sedimentary rocks. Limestone can form from pieces on the hard skeletons and shells of sea animals that lived long ago. The pieces are held together by dissolved minerals. Limestone is used to make cement and steel. Sandstone, which is used to build homes, is a sedimentary rock. Sandstones can form from pieces of minerals and tiny grains of rock. Sedimentary rock, such as shale or sandstone, is made up of very tiny bits. These bits settle to the bottom of lakes or oceans. Shale can be made into bricks and cement. Can you see the skeletons and shells of sea animals that make up this sedimentary rock? Metamorphic rock. It is very hot deep inside Earth. There is a lot of pressure. The weight of rocks presses down on rocks below them. This heat and pressure can change how the particles in the rocks are arranged. It changes the properties of the rock. When this happens, metamorphic rocks form. Metamorphic means change in form. Metamorphic rocks change from igneous, sedimentary, or other metamorphic rocks. There are many ways metamorphic rocks can change as it forms. The mineral crystals in the rocks can be changed by heat and pressure. They can change size and shape. The chemicals in the rocks can even form new minerals. This diagram shows the inside of the Earth. Heat and pressure inside Earth make metamorphic rocks. Types of metamorphic rocks and their uses. Metamorphic rocks are usually hard. Heat and pressure can make the rock particles form into layers. Because of this, some metamorphic rocks also chip into flat sheets or slabs. Slate is one type of metamorphic rock. It starts as shale, which is a sedimentary rock. Slate is often used to make roof tiles because of its strength. The igneous rock granite often becomes gneiss under the heat and pressure. Limestone and dolomite can change into marble, a very strong and beautiful rock used in construction and in sculpture. Granite left can become gneiss, right. Limestone left can become marble, right. Reviewing the rock cycle. You have learned that any type of rock can change into metamorphic rock. In fact, all types of rocks are changing all the time. The recycling of old rocks into new is an ongoing process called the rock cycle. Rocks can change from one kind to the other in any order, but sometimes they stay the same for millions of years. Look at the diagram of the rock cycle on page 23. Some rocks go through the whole rock cycle. Other rocks, such as those deep in Earth's crust, may never reach the surface, or sedimentary rocks may change into igneous rocks but never become metamorphic rocks. Igneous rock left can change into sedimentary rock right during the rock cycle. Igneous rock, melting, heat and pressure, weathering and erosion, sediments, erosion, pressure, sedimentary rock, heat and pressure, metamorphic rock, melting, magma, cooling and hardening. Glossary. Cleavage, property of minerals that break along smooth, flat surfaces. Igneous, type of rock that forms from molten rock. Luster, property of a mineral that describes how the mineral reflects light. Metamorphic, type of rock formed when heat and pressure change the properties of rock. Mineral, a natural non-living solid crystal that makes up with rocks. Ore, a rock rich in valuable minerals that can be removed from Earth's crust. Rock cycle, the process that recycles rock into new types of rock. Sedimentary, type of rock that forms when layers of sediments settle on top of one another and harden.